So Count Dracula fires this egg at 25 meters per second. Let's draw that vector first. So there's the vector, 25 meters per second at an angle of 35 degrees. Okay? Now, the first thing we have to do is break that vector into components. What do the components look like? Well, the components look like this. The x component along the horizontal, and the y component along the vertical. How do we find their magnitudes? Well, for the x, any vector, in this case 25 meters per second, times the cosine of the angle it makes, in this case 35 degrees, is equal to its x component. 20.48 meters per second. For the y component, it's 25 meters per second times the sine of the angle it makes, which gives us 14.34 meters per second. So now what do we do? With this data? We break it into x and y components. Now we make an x and y chart. Our x values and our y values. We know the initial velocity in the x is 20.48 meters per second, and we know the initial value of the y velocity is 14.34 meters per second. We know that the acceleration in the x never changes. Nothing makes it go faster or slower in the x direction. We know that in the y, we have to deal with gravity. Gravity causes things to fall towards the earth at 9.81 meters per second squared. So the final velocity in the x is going to be equal to the initial velocity. Again, no change, no acceleration. The final velocity in the y is a little harder. We don't really know, but we do know something about the apex. When a projectile is fired, we get this nice parabolic path, and at the apex, the velocity in the y achieves 0 meters per second. So I can use that knowledge to help me solve the problems. dx, I don't know. It's one of the things I'm looking for in this problem. And dy, I don't know. Again, one of the things I might be looking for at the apex. Finally, time. I always write time under the y column because although time acts in both the x and the y direction, time is controlled by the vertical. Okay, now let's solve for time first. The equation that helps us solve for time is VFY equals VIY plus AYT. Notice I write y for each one so that I don't confuse my variables and use something from the x value column. So I set that equal to the apex, 0 meters per second equals our initial velocity in the y, 14.34 meters per second, plus negative 9.81 meters per second squared times t. Solving for t equals 1.46 seconds. Remember that is just t to the apex, so I label it t up. And according to the philosopher Alicia Keys, what goes up must come down. So t down also has to be equal to 1.46 seconds, giving us a time total of 2.92 seconds. Now I can use my time to find my displacements in both the x and the y. I'm going to find the maximum height first. Maximum height is given by dy equals VIYT plus 1/2 AYT squared. Substituting values now to solve. 14.34 meters per second times the time up, 1.46 seconds, plus 1/2 of negative 9.81 meters per second squared times 1.46 seconds squared gives me 10.46 meters. So in fact, he does clear the castle. Now in terms of the distance in the x direction, the same equation is used. Dx equals VIXT plus 1/2 AXT squared. Remember now that I have to use the total time to solve for dx. I know my initial velocity, 20.48 meters per second, times the total time in the air, 2.92 seconds, plus 0. Why 0? Well, you'll recall that AX is equal to 0. Any number times 0 is equal to itself. So I get a distance of 59.8 meters. And depending on your perspective, that's either hitting the ghost, who was at 60 meters away, or just missing the ghost at 60 meters away. I would really have accepted either answer. So there's your answer for dx. Here's your answer for maximum dy. And that's a ground launch projectile problem. See you in class.